Hi students, welcome to our science class. Our chapter name is Fun with Magnets. This is one physics chapter and in this chapter we are going to deal with completely magnets. Actually you are familiar with this term magnet and also familiar with the substance magnet, and so we are going to study some sort of properties, what is magnet, how we invented this magnet, what is the history, like things we are going to discuss in this chapter. As the introduction, I'm just going to say something. Today I just went for the morning walk and at that time I just observed something. A huge heap of waste materials. Huge heap of waste materials, and near this heap there we have one crane. At the tip of the crane there we have one block, a particular rectangular shape block. And the thing is this, when the block is moving towards this waste, some special things are jumping towards this block. Actually, that special things are these: some iron junk. Iron junk means iron waste. So the thing that inside this waste, which is iron, is just jumping towards this block. Why? What is the reason? That means this substance is something that sticks the iron, or I am just restating this: sticks means attracts. This block or this cube is something that attracts iron. And what is that? We can name that. And the another example is this: you may observe in your home that the pin holder. The diagram you can see in your textbook, and the thing is this: all the pin is getting stick on this. This is the pin holder. And so, why this pin is not sticking on this beaker but on this central rod? What is the reason? So I can say this rod and the block that is attached on the crane, both of the things are same. Both of the things are same. And also I will tell another example. Here you can see something. What is this? This is one pencil box. You may have this. And here when I close this, have any lock mechanism is here? No, but it is just locked. When I just put this near to this box, what is happening here? There is no such lock mechanism is there. Only you can see here something is there, and here also something is there. Actually, this piece is getting attracted towards this. It is just jumping and just stick there. The similar thing happens this side also. You can see here a piece is there and this is getting stick on this side. So this and the case of the crane, all these things are same. All are behaving similar and all these things are same, and I am going to call it as magnet. So we can say, simply we can say it attracts iron. Actually, but the thing is this, not only the iron but also some other metals are also attracted by the magnet. I am not saying that all the metals will get attracted to magnet, not like that, but still some of the metals are attracting not only iron but also some other metals are there, we can discuss. So we can say generally, simply we can say magnet is something that attracts iron. That's mentioned in your textbook. So within your level, within your 6th standard, you can say it like that. Now the question is this. Do the name of this substance is magnet from the previous initial stage? No, it is named later. And how this magnet is invented? Do all the magnets are similar? Have any difference? Have any classification? All these things we are going to discuss in this region. So, now we are going to discuss how we invented magnet. That is the next portion. How we invented magnet. How invented magnet? How invented magnet? Who invented magnet? Like the things are many questions are there. This is actually somehow maybe myth or something, but this we are just believing like that. So the thing is this. Once one shepherd named Magnus just took his sheep, goats and all and just go to graze. And at that time, accidentally he met something. That means, at the time of gazing, they have one rock. And at that time, in his hand, there is having a stick. In his hand, there is having a stick. And at the tip of the stick, they have one iron piece. Iron piece is there attached at the tip of the stick of the shepherd, and his name is Magnus. And so, this is our Magnus. When he is walking and accidentally this happened that his stick is got struck on this rock. And later he understood that this iron piece is responsible for this. And when he is trying to push this, nothing happens because this attracts or this sticks this piece of iron. And so that is what, this is our magnet. Now we can call it as magnet, and at that time it's named as lodestone. L-O-D-E, lodestone. Lodestone. So simply we can say the material of magnet, the material of natural magnet is lodestone. That is its name. And so, what is this lodestone? What is the substance? The lodestone is nothing but magnetite. Actually, this magnet is the name of that substance, and this magnetite is the real name. Now we are just simply calling it as magnet. And actually what is the name? Magnetite. That is the substance. This magnetite is made up of, it contains iron also. I am not saying that iron is called magnetite, not like that. But even this magnetite contains iron particles. So it contains iron. So this is the thing. And this is one story. And in another some books we can see that this Magnus wore some shoe. That shoe is made of iron. The sole is made of iron. And when he is walking through the rock, what happens? He is just struck on the rock. That is also in some books we can see like that. So these all are stories. So just leave it. And here you just want to remember the name of the magnet. The substance is lodestone and the real name is magnetite. Magnetite. So I can say The simple definition of magnet that is mentioned in your textbook is this. The substance which have magnetic property is called magnet. So the substances which have magnetic property is called magnet. The thing is this magnet shows some properties. One of the properties is this, the magnet attracts iron, some metals. So that is one property. Another properties are about its poles, about the attraction, about the lines and all that you will study in detail in your higher classes. And here now just study the substance have or which shows magnetic property is called what? Magnet. So this is the definition. Now we are going to classify this magnet. Do all the magnets are same? No. And you can see the magnet in the clock or the alarms, the speakers and everywhere. Do the same thing is at the previous rock? Actually the thing is different. The rock that we found at the previous age of magnets is what? Natural magnet. That is, it is made from nature. It is natural. It's not made by human beings. But now we can make the magnet using the iron. Using the iron we can make magnets, and that is called what? Artificial magnets. So we can classify the magnets into two. One is natural magnet and the another one is artificial magnet. Natural magnet and artificial. What is this natural magnet? The magnet which is found in nature, in the natural state. And the artificial magnet is the magnet which is made by human beings using iron or something. So natural magnets are the, artificial magnets are the. Now we are just removing all this and focusing on this artificial magnets. Do all the artificial magnets are in similar shape? No. We can see different types or different shape magnets are there. Even if within the artificial magnet, another type, the permanent magnet is the temporary magnet is there, that you can study in your higher classes. Now we are going to study the classification of artificial magnets according to its shape. So we already said that we can see the magnet in different objects. What substances or what devices which produce and generally contain a piece of magnet inside that? That is the general concept. So the thing is this, inside each device, the size is different, the shape is different, and also by considering its shape, it is having different name. Now we are going to study the name of the magnets with different shapes and all. Some magnets are like this. And this is called bar magnet. Bar magnet. It's in the shape of a bar. Bar magnet. And generally these bar magnets are shaded this region with some sort of paint. So this is called bar magnet. This is the name of this magnet. And the next is this, the magnets which is in the shape like this. And the shaded portion will be here. What is the name of this magnet? It is actually in the shape of horseshoe. And the name is this horseshoe magnet. Horseshoe magnet. Considering it as the shape of the shoe of horse. And so it is horseshoe magnet. So we studied bar magnet is there, horseshoe magnet is there, then cylindrical magnet. Cylindrical magnet. So this magnet is in cylindrical shape and it's called cylindrical magnet. The another magnet is the one rod and the two ends, two balls are there present, two balls. So the name of this magnet is this ball-ended magnet. Ball-ended magnet. So there are more magnets are there, like disc magnet. That means the magnet is in the shape of disc. Some sort of chapati like that. So disc magnet. Disc magnet is there. Like different types of magnets are there. So these are some of the names. Bar magnet, horseshoe magnet, cylindrical magnet, ball-ended magnet, disc magnet, like different magnets. These all names are based on the shape of the magnet. So just understand there are different types of magnet and we are classifying it in the terms of shape. So we can design magnets in different shapes and you can see some sort of shading is there for each and every magnet. That is having a reason that we can discuss later. So this is about the shape and its classification. Now the thing is this. One activity is there mentioned in the textbook. Very simple activity. Just read it. And the thing is this. We are just taking one stand. And in this stand I am just clamping one paper glass. That means I am just fixing one paper glass and put one magnet inside this glass. I am just keeping one magnet inside this glass and closing this. And now I am just taking one paper pin. I am just taking one paper pin and attaching one small thread on this paper pin. And now I am just taking this paper clip near to this magnet. That means near to our paper glass. And then you can see this. Our paper clip will just float like a kite. Just float like a kite or just stand without any support or something. The reason is this, actually our magnet attracts this paper clip. This paper clip is not plastic, it is some sort of metal, we can call it as iron. So this paper clip is made of iron and because of that this magnet attracts this. So this activity or this experiment only mention, they are just meaning that this iron is getting attracted to magnets. That's all. No more confusion or nothing. This is all about this. Now the question is this. Do all the substances attract magnet? No. The thing is this. I already mentioned our paper clip is not plastic. What happens to the plastic if this paper pin? It do not attracts this magnet. So this magnet is not at all attracting some substances, but it attracts some substances. Now we are going to deal with that. That means I am classifying the materials. Materials. I am going to classify. Material means all materials into two by the attraction of magnets. That means some of the substances are attracting to magnet and some of the substances are not attracting to magnet. So, by considering that two classifications, and I am going to give the name magnetic material. Magnetic material and non-magnetic material. So the thing is this magnetic material and non-magnetic material. What is this magnetic material? The material which attracts magnet is magnetic material. That means the substances which attracts by magnet. And non-magnetic material is the material which do not attract by magnet. So, attract by magnet and do not attract by magnet. Now we just want to study some examples for this magnetic material and non-magnetic material. What is the example for this magnetic material? Very simple. One is our iron. This you already know. Now you just want to remember more examples, and that we are going to study here. Nickel, cobalt. These are the substances like this iron. That means these are some metals which attract by magnet. So just remember, not only the iron but also some other metals are attracting by magnet. And the examples are iron, nickel, cobalt, etc. And the next is the materials that do not attract by magnet. It is very simple, that plastic, leather, gold, paper. These all are the examples for the non-magnetic material. That means these substances do not attract by magnets. Plastic, leather, gold, paper, like anything you can write which do not attract magnet. You can add the examples. So, these are the classification. Materials are classified into magnetic material and non-magnetic material. Now the question is this. We are just considering soil. Is it in the category of magnetic material or non-magnetic material? What is the thing? Do the soil is attracting to magnet? You may say that no. But the thing is something different. The reason is this. Not all the soil is same. When we are considering different region within the Kerala itself, or within the soil from the different regions in our country, not all the soil is same. All the soil is different and it contains different particles are there. And so we are just going to do one activity using the soil. Within a beaker, we are just collecting some soil particles, and then take one bar magnet. Taking one bar magnet and take this bar magnet and put it in the soil and rubbing it to the soil. Rubbing. So I can take soil A, soil B, soil C. That means there are different types of soils are there, and so you may study in the geography and all. So the thing is this. The result on this magnet is different with different soil. That means you will get three types of results. The thing is this. One magnet, second, third. First combination, you can see many particles are getting stick on the magnet. This is one result, A. The second result, some particles are getting stick on. Here many particles are there. Here some particles are there, and C, no particles are there stick on the magnet. This all we did with different types of soil. And so what we get from the soil? some sort of thing is getting attracted on magnet. So the thing is this is actually iron fillings. Iron fillings. Iron fillings means powder of iron. So we can say some soil contain iron fillings and so that powder is getting attracted on the piece of magnet. So we can say in some region they have iron fillings and that is getting attracted on magnet. Some region this iron fillings concentration is very less and so few of the particles are getting attracted, and in some region no iron particles are attracted. So generally we are not possible to say within the soil is it magnetic or not possible to say, but if we get the sample and we are just doing the experiment, we can identify is it magnetic or non-magnetic property soil. So this is about the activity and this is also mentioned in your textbook, just read it. Now just observe here. Why I just draw this diagram like this. You can see that I just put the dots at this end and this end. Why I am not giving dots at this side? Why? And here also I am not drawing any dots here. I am concentrating at these two ends. And what is the reason? That now we are going to study. For that, we are just taking a piece of paper. We are just taking a piece of paper and then put some iron fillings on this paper. Iron fillings. And just spreading on this paper. And now I am just taking one bar magnet and putting on this paper, and on the paper we have iron fillings, and so you can see this all iron fillings are get attracted at these two ends. What is the reason? Actually, for a magnet, its attraction or the power is concentrated on a particular region, and I can call it as pole. Pole of magnet. That means the attraction, the power of magnet is getting concentrated on a particular region of magnet, and so I can call it as pole. And now the question is this: how many poles are there for a magnet? Here, how many poles? When you observe the diagram, you can see that here the iron fillings are attracting or focusing on 2 points. And I can say 2 poles are there for this magnet. And now I am just cutting this magnet into 2. Now this is one magnet and this is one magnet. Do this magnet have one pole and have one pole? No. Now you can see the iron fillings are getting attracted at this point and this point. Whatever the size, always, whatever the shape, no problem, always and always we will get 2 poles for the magnet. That means our magnet is dipolar. That means magnet is always having 2 poles. It's not possible to make a magnet with a single pole. Within our level, within our inventions, it's not possible to make a magnet with a single pole. Always we have 2 poles. And so, for this activity, this is our aim, that for a magnet, it is having the power is concentrated on particular region, and that is called what? Poles. For a magnet, it is having 2 poles, and I can say it is dipolar. A magnet is dipolar. And what is the name of this pole? Have any particular name for this? What is the name? And when you observe the diagram of the magnets, you can see in some magnets, you can see N and S on the magnets. What is this N and S of this magnet? N is the North Pole. And S is the South Pole. North Pole and South Pole. So for all the magnets, when it's in the shape of, this is the bar magnet, when is our horseshoe magnet, north is this and south is this. For all types of the magnet, it is having two poles. One north pole is there and south pole. When I am cutting this magnet into two, what happens here? The south pole comes and here the north pole comes. Always it's like that. So whatever the shape of the magnet, what's the size, doesn't matter. It always have the north pole is there, south pole is there, and by considering the size, the power is getting different. Some magnets are very weak, some are very powerful. But the thing is this, always it have north pole and south pole. And now the question is this: why we are giving the name for the magnet is north pole? Why it is south pole? Why we are not giving west pole and east pole? What is the reason? It is having proper reason, and we can discuss it in the next class. Now you just want to read your textbook and also want to complete your notebook. We will meet in the next class with the further topics. And this is all enough for today. Thank you.